Morning, everyone. It's good to have everyone back. Well, most everyone back. It looks like people really enjoyed the party last night. Looks like we're missing a couple people here, but overall a great session. So thank you for day 2, coming back for Hadoop Summit. We've got a great agenda in terms of what we've got set up for day 2. I know a lot of people really enjoyed the breakout sessions yesterday, heard a lot of good comments from the different sessions that people went through yesterday. So first, I think we need to go acknowledge the party we had last night. Who enjoyed the party last night at Auto World? A great venue overall. One, you get to see a lot of classic cars and motorcycles, great food and great drink. Heard a great comments about the band in terms of when the band came on and what was happening. And the part that I found most interesting of the evening is you see that little giraffe over there on the right. There's a group of you, and I can't figure out who it was, but I heard them talking last night about having a resurrection, taking the giraffe and replacing it with an elephant. I'm glad it didn't happen. It would have been a high security deposit with Auto World, but things went well. So thank you. I'm glad everyone had a good time. Now, for those of you who had too good a time, we didn't see you on the bike ride this morning. So just so you know, there was a group of about 50 people who did the Hadoop Summit Brussels bike ride about 6 a.m. this morning. And for those of you next year who want to do it, great ride just going through the city. Not a hard cycling ride, but I think people had a lot of fun touring the city, but also going out there early and getting to see the sunrise in Brussels, which is a great experience. So we welcome you all back next year, anyone who wants to join that. So we've got a great day scheduled. So first we'll start off with the keynotes again, and I'll introduce the first keynote in a minute. We'll go to a break. A little bit different. We've got the breakout sessions split across lunch today. So great opportunity again at lunch to spend time down in the community showcase, and also the breakout sessions that you should have in your mobile app and in the abstracts going through. One thing a little different at the end of day today, I'd highly encourage people to go join the Birds of a Feather session. Each of these sessions is led by a committer, and it's a great opportunity to get into a smaller group setting and be able to ask much deeper questions and get into a roundtable discussion about each of the particular Apache projects. Some of the more existing ones that people probably know, like Hive or Yarn or HDFS, and especially on the newer ones if you want to spend time around streaming with Storm, security, and what you can do with centralized security and Ranger, or Tez as an underlying component on top of Yarn. So great opportunity in the Birds of a Feather session to learn and to get a much deeper dive into each of those technologies, and that'll be this afternoon. We have Cafe Hadoop again. Thank you to all our tech titans. Appreciate you spending the time helping to give everyone a hands-on experience in Cafe Hadoop with HDP and to go start playing with Hadoop in a live session. And again, we will have many more tech titans both in Hadoop Summit San Jose as well as next year in Hadoop Summit Europe. So I welcome anyone who would like to go join that program and participate and start to leverage their skills more broadly with the community. So a couple reminders, everyone should still have wireless set up, everything from yesterday, so I assume everyone's good on this. From the tweeting perspective, right, we mentioned yesterday, get social with the community and win and get talking. So who knows, pick a number, how many, the most number of tweets by an individual have been out there so far? Somebody yell out a number.
80.
All right, we got 80. Anyone else? It's not 80. 10. Okay, it's between 10 and 80. So, somebody guess. Humor me. 40, okay. The answer is 27. Okay, 27 tweets. Let me ask you, is there anyone here who doesn't think they can do probably 28 to 30 tweets sometime in the morning to go win an iPad or a GoPro? It's actually not that many. So game on, everyone. Let's go see what you can do out there. But really, it's a pretty low bar right now, and I'm sorry, I don't know who has 27. I won't call you out. But it's a pretty low bar, and there's an opportunity for this. This game is far from over in terms of just being able to talk about what you're experiencing and your thoughts overall on this. Okay? So with that, we've got a packed agenda. We will stay on time today. Apologize we went over a little bit yesterday. We will stay on time. So what I'd like to do is invite our first presenter up, Aidan O'Brien. Aidan O'Brien, come on up from EMC. Aidan runs Big Data and Strategy at EMC. We're excited to have him on. 1 as a Diamond sponsor, 2 as a partner of Hortonworks, and 3 as a fantastic presenter. Aidan, here you go.
Thank you, Herb. Thank you. Good morning, everybody. Thank you for having me. For those of you who don't know me, my name is Aidan O'Brien. I'm British. I work for a shared storage company, EMC, and I have a background in financial services and management consultancy. I'm generally very nervous about presenting in continental Europe, and especially here in Brussels, because I tend to see I have the ability to actually anger about 94% of everybody in any given room simply by telling you who I am. Thank you for that laughter. I wasn't even expecting that. There must be a few British people here in the room, because the Germans never laugh at that first joke, or any joke for that matter. In actual fact, I like to say to my German friends, I say, you are now so much better than us at football, but we still remain at a significant advantage in sarcasm. But anyway, I digress, and we're only 32 seconds in. It's starting to feel like a meeting in Paris, except for the fact that we started on time. So, with that said, hopefully many of you enjoyed on Tuesday night the session about Formula One. And I think it's now pretty well understood that big data and analytics is starting to become much more impressive across a number of different sports. Obviously, professional football, it's well understood. SAP have just announced their equestrian analytics platform. And we too at EMC have our own motorsports initiatives as well. This is John McGuinness. He's actually the fastest man on earth on a motorbike. He's won the Isle of Man time trial 21 times in 25 years. And it's very interesting when you speak to John and you say, John, how do you do it? Why are you the fastest man on the earth? And he looks at you and he says, I have no idea. And so what we actually did was we took John, we took him down to northern Spain, we put him in this sort of EMC leathers, replete with thousands of biometric sensors, and we sort of raced him around for a couple of days. And what we've actually done is we've made that data set available. We're actually launching a competition, so you guys can get access to that data, and you can actually work out why he's the fastest man on Earth. So if you want to know more about that competition and get involved, then please come down to the booth as well. But I think, so that's sport and that's fine, but I think what we're also seeing, and the reason why we're here, is that we're seeing that all industries are actually sort of benefiting and taking advantage of big data. And as much as, often the advances are incremental in nature and they're not always immediately transformational, all industries are benefiting, including even the oldest and the heaviest industries. Now, you don't need me to talk to you about prescriptive planting or sort of the industrial internet and what companies like GE are doing. I'm sure you're all aware of companies like Rolls-Royce who have now revolutionized their business, where now they effectively give away those jet engines and they sell them with a multi-year services contract. So as those engines are attached to planes, they're sending back data in real time to a center in Derby in the UK, and that data is actually getting run against a number of pre-built analytical models where actual behavior is getting compared to estimated or predicted behavior for components of that sort of a longevity and number of flight hours. And that's allowing Rolls-Royce to advise the logistics firms of when components are going to fail, meaning those replacement components can be at the gate for when the plane actually lands, allowing the changes to be made immediately, allowing the plane to get away on time on its return leg, meaning that delays are avoided. What we're seeing and what we recognize is that the center of business value is actually changing. It's no longer about the product, it's about the data about the product. So the future of your business is not your product, but the data about your product. So I think we can all probably agree that big data presents a huge opportunity, otherwise we wouldn't be here. That then begs the question of, well, how do we go after this opportunity? At its simplest, we believe there are three things you need to do. The first is to gather and collect as much data as possible, which is obviously why Hadoop plays such an important role in this. Analyze that data to understand the key insights, and then from there, well, what we don't do is just copy and paste those insights into PowerPoint, because obviously PowerPoint is where insights go to die, but we actually then go and build these new data-driven analytical applications that allow businesses to change the experience they give to their customers and to their employees as well. So that's the reason why we sort of at EMC, the Federation, we actually believe that the business data lake construct is absolutely crucial to allowing sort of customers and yourselves to actually bring together data, analytics, and applications. And what we see is that, we believe that the time is now because of the convergence of these 5 key trends in the market. So obviously the explosion of, the growth of data, the limitless compute effectively that we see now, the advances in real-time technology, the maturation of the DevOps movement, and of course one that's acutely sort of close to our heart at EMC as well is, increasingly cheaper storage as well. So if we now go where we see this opportunity, we now understand, sort of what we need to do to go after it and what's the construct or the thing that we need, the widget that we need. That begs the question, well, why aren't more people actually doing it? And quite simply, because it's hard. What we see is that, on the technology side, it's typically taking customers between 4 and 6 months to stand up these big data environments. And these IT departments are absolutely petrified about obtaining the skills and then also actually maintaining them in a fast-moving environment. On the business side, what we see is there's lots of organizations that don't know the first use case to go after. And for those organizations that do know that first use case, what we see is everybody's use case is slightly different, and because they're all trying to achieve a competitive advantage. So the knock-on effect of that is that the technology sets they're using across NoSQL databases, graph databases, analytical visualization tools, underlying storage, they all tend to be somewhat unique in nature. So the net of that is that we believe that organizations need a solution that, on the one hand, gives them greater standardization to allow them to stand up these platforms more quickly, and we'll come back to the idea of standardization at the end of the presentation, yet at the same time deliver flexibility to actually allow them to pick and choose the technologies they need to go after this opportunity. So it's that mix of standardization, yet flexibility, which is difficult. That's obviously what we try to actually resolve by giving you guys the big easy button for big data. We really want to give you the click button, get cluster experience, but for the whole big data environment. And so this is the sort of the solution that we announced earlier this year, and that will continue to sort of build out throughout the course of the year. Basically what we've done is, if you think back to the idea of collecting all that data, analyzing it, building the new data-driven apps, this is how we've lined up our own Federation technologies from across the 5 companies that make up the EMC Federation. And so what you see is, we include the different storage products, the virtualization products from VMware, Pivotal's Analytics Suite, and the Big Data Suite, and also Pivotal Cloud Foundry. That's all great, and we're very proud and very happy with that portfolio, but we recognize that when you guys are trying to deliver on use cases, we don't have in-house in our portfolio all of the technologies that you need. So for example, you would need visualization tools. So that's the reason why we at EMC are absolutely firm believers in the need to embrace the ecosystem of partners that are out there. And that's the reason why we embed third-party technologies into this platform. And when I actually sort of say embedding third-party technologies, we essentially create a VApp and drop it into that environment to make it available on top of this platform. The other thing which would actually sort of we've gone and done in addition to those first 2 elements is we recognize that just having all those technologies alongside each other is precisely that, having a set of technologies that work alongside each other. That doesn't necessarily make a living, breathing business data lake platform. And that's the reason why we're focused on, building and extending, sort of 3 key components, which I'll sort of take you through now. If you think what you need to do in this environment, there's essentially 4 things. You need to be able to stand up and instantiate the technologies, put the data in there, take the data out of there, and across that whole environment, manage the controls and the access and the permission to that environment. And that's what these 3 components do. So the Data Lake Platform Manager will allow you to stand up the environment, ingest the data, index it as it goes in. The data and analytics catalog allows you to actually sort of consume the insights and the data, either if you're an application or if you're a particular type of end user, such as a data scientist or an application developer or a business analyst. And then the management of the access and permissions across that whole environment, that's the central component of the data governor on the right-hand side. So if you want to hear more about that solution, then please, I invite you to come down to our booth to talk to some of the technical experts that are building that at the minute. So what I'm going to do, so with that, let me thank you for your time this morning. Hopefully this has been a British foray into continental Europe that's been vaguely useful for once. What I'd like to do is I'd like to hand across to my dear friend and colleague from Pivotal, from California, Leo Spiegel, and he's going to talk to you a bit more about the idea of standardization in the context of the ODP initiative, which I'm sure you've obviously heard a lot about this week as well. So I just need to be careful before Leo comes on because he's a hugger. So being a British person, I have an issue with personal space, so I'm going to see if I can get off the stage without being hugged by Leo.
I don't know if it's an American thing or a Leo thing. Anyway, good morning, and thank you very much for allowing us to present the Open Data Platform Initiative. I'm really honored on behalf of the members of ODP to give you a preview and an update on what we've been doing. ODP is a whopping 60 days old or so, and I think in the first 60 days, we've accomplished a lot, and I'd like to share that with you. So first, for those who don't know about ODP, and I'm sure everyone in this room hopefully does, it's really a shared industry effort to help promote and advance the state of Apache Hadoop and big data technologies for the enterprise. And when I think about ODP, and I've been involved in really creating it, for me it's about community, it's about cooperation, and it's about accelerating the big data ecosystem. And I think all of those things are good for everybody in this room and in the industry. And I hope that people will think about embracing ODP as a way to really do good things in a very constructive and positive way. Here are the current members, and it's a fantastic list. And ODP is open to everybody, and I really believe you'll see a tremendous amount of new companies joining over the coming months. And I'm going to make a few firsts, and so I am announcing for the first time on behalf of ODP a new membership level. It's the silver level, and this level is designed for people in and around the industry, ISVs, people building applications, and most importantly, enterprises. It's a very low bar. It's $1,000 a year to $5,000 a year. So any company can join ODP. There's no big monetary responsibility, and what we really want you to do is join our community and help us do good. I think as we think about accelerating the delivery of big data solutions and providing this predictable and version-consistent core, I mean, that's at the heart of the nugget of what we're trying to do. And so we've agreed to a set of bits that come 100% from Apache, and those bits will be the same bits in each ODP distribution. And that's really fundamentally what we're trying to do. And I think it's very obvious that by doing that, we ensure that enterprises have a consistent version. When I spend a lot of my time with CIOs all over the world, and they have many different distributions. It's not always just a single vendor's distribution. And so they now will know that if it's ODP compliant, that those distributions are consistent. And then more importantly, for people who are targeting and building applications, they know that if they test their solution on an ODP compliant distribution, it will work, whether it's ours or someone else's. And I think that's really key and important to the industry. So we're also really trying to provide a model that harmonizes upstream community innovation with downstream enterprise consumption. And I think this is really key because there's been a little bit of confusion. I'm not sure why, but again, I'm going to be super direct. ODP is 100% complementary to the Apache Software Foundation, full stop. Everything that happens with regard to engineering related to ODP is done in the Apache processes. Contributions, all the process, all the IP, all of the guidelines are the Apache Software Foundation issues. ODP is not getting involved in any of those things. And we're really trying to promote a Hadoop community for development and outreach activities. So again, 60 days in, and I was involved in creating the Cloud Foundry Foundation, for those of you who are involved in applications and basically the PaaS space. I can tell you I've done a lot of interesting things in my career, but getting 50 companies to agree on guidelines and governance and all that kind of stuff was a fascinating experience. And I think we've done more in 60 days at ODP than we've done in many ways with regard to Cloud Foundry in the first 6 months of its existence. Now, a year later, obviously, Cloud Foundry's gone a long way. So, again, 60 days in, we announced, and I know Rob was up here with IBM, there are now today 4 ODP compliant distributions. So you heard about Hortonworks, you heard about IBM, you heard about Pivotal, and today I'm announcing that Infosys's version of Hadoop distribution is ODP compliant. And what that means is that it's using Apache Hadoop 2.6 and it's using Apache Mbari. And again, it's to improve ecosystem interoperability. It unlocks customer choice, eliminates the guesswork around these distributions, and 100% respects the Apache way. A couple more things that we've started to do, and we're really trying to get very tactical so we can demonstrate value to the marketplace. So 2 things. We'll be having on April 21st, next week, in the Bay Area, our first session, and you can see that I think when this was produced a few days ago, we already had 77 people who had signed up to attend, but we're educating developers on how to become Apache contributors. So we've created a curriculum to help them accelerate and figure out how to become contributors in the Apache system. The other thing that we're doing, and we're doing this in May, is there are approximately 6,000 Hadoop Jira issues, bugs, in the core Apache products. And we're bringing together a whole bunch of contributors and developers, and we're going to get together in a room, and we're going to basically knock down the bug list. We're going to solve bugs in Apache. So these are very tangible things that are open to everybody. We encourage everyone to come and join us as, again, we try to accelerate and improve what's going on in and around the Apache ecosystem. Let me just share with you the guiding principles. And again, this is one of the first times that we've published these. And again, we've just started to work together to create these things. First and foremost, we want to provide a stable, predictable, and enterprise-ready ODP core. The second one is really important, and I really hope you'll listen to my words. It's a one-member, one-vote system. It doesn't matter if you're platinum, if you're silver, or you're gold. If you're a member of ODP, you have a vote. So it's a very democratic system to ensure that what we're doing benefits the industry. It's 100% complementary to the ASF, full stop. It's a completely transparent technical process. Everything we do will be published and available on our website. Equal opportunity to participate in all development efforts, again, using the Apache processes. But there's no, anyone can join, anyone can participate. And really our goal is to create this amazing community of people who are committed to improving and accelerating the big data ecosystem. And then lastly, and this is something we learned in the Cloud Foundry experience, basically no surprises. So planning processes and project statuses are open to all. So let me just talk about some of the actions that were underway already in our first 60 days. We've got a bunch of committees, and again, I hope you'll join us in this process and join some of these committees. But we've got a governance and structure committee that's working, and we intend to stand up the actual organization from a legal perspective, within weeks, time frame. I mean, very, very rapidly. We've got a technical development community. We have market and awareness committees, and then we have this Apache Assist program. We've also began sourcing our executive director and staff, and I encourage anyone in the room who's interested in joining the ODP team to go to our website and think about applying and helping us do something that's great for the industry. We're talking about further refinement of the ODP-related technologies. We've been getting a lot of really good feedback from participants in the ecosystem, enterprises, and we're open. I mean, we're really trying to do good, and so if you have opinions about how we should think about changing what is the core of ODP, or where we should be focusing our energy from a development and technology perspective, we're very, very open. And then a couple things just to give you a taste of some of the things that we're thinking about. We're thinking about this notion of an ODP-sponsored developer program. So we're fortunate in ODP that because we've got sponsors who are writing big checks, that we can use those dollars, again, to accelerate development in and around this ecosystem. And so ODP will be looking to fund developers who will work on Apache projects to, again, help accelerate the big data system. And we're still trying to figure out how to do that. Obviously, we don't want to compete with companies where these people might be working, but I think we can come up with an interesting way to do that. And then another thing that we're really excited about, and this is something that I feel very passionately about, because as I said, I spend a lot of time with CIOs. We're really trying to come up with a certification and education program for universities around Hadoop and big data technologies that we can drive globally. Because one of the big challenges I think we have in this industry is we don't have enough experts. And we need to develop a bigger generation, if you will, of expertise in and around these technologies. So how can you participate? Anyone can join, $1,000 or less. Leverage our core to accelerate your solutions. Contribute people, test code to accelerate the vision. And lastly, please visit our website at odpplatform.org for more information. Thank you very much.
Thank you, Leo.
Thank you, buddy.
Thank you. It's great to talk about ODP, and I will just say, as Hortonworks, we're obviously very excited to participate in that. Just from what we're seeing already and what it's driving in collaboration across all the different companies who are participating to say, how do we have some level of standardization to make it easy to certify once and then deploy anywhere across the application? So it's something we've seen a lot of interest in, and we feel that we're privileged to be able to participate in that. So now we actually have what's my favorite part of the entire session, and hopefully for the rest of the audience as well. And this is a customer panel. So let me invite out Fred. Welcome.
Thank you.
Oh, let me get to the slide. Welcome. Thomas. Daljit. Bernhard. So as a customer panel, this is an opportunity. We'll go through it. We'll just ask questions of the group and just walk through some different use cases and thoughts of how they leverage Hadoop. And it's an opportunity to hear from different companies, and we're very privileged to have them all as customers, but different companies who are already partly down that Hadoop journey and some very far down the Hadoop journey to give their perspective on what they're doing with Hadoop from a transformational perspective, how pervasive they see it across their enterprise, and what are some of the enterprise class capabilities that they take advantage of as they start leveraging Hadoop across their businesses. So with that, I think the best way to start probably would just be to have each person introduce themselves, a little bit on their role in each of their organizations. And what I think would be helpful, if you guys are open to it, is just to talk a little bit about their first use case and how did they get started with Hadoop and what are they doing from a business perspective. So Fred, why don't we just start with you first?
Yes, okay, thank you, Herb. Yes, I work for KPN in the Netherlands. KPN is the incumbent network operator, telecom service provider, but KPN also has an IT solutions department. My role is I'm product manager for Hadoop as a service. What we, as IT solutions, realized that the world was changing, and we saw this whole, all the dynamics going on in the big data environment and around Hadoop. So we started a market research and see what that would mean for us as an IT solution provider. And for us, that was a clear recommendation that there was a clear role for a trusted party to deliver Hadoop as a service in the Dutch market. Another part of delivering this service is also that we realize that there's a lot of customers that start to realize that they have lots of data in their existing systems. They get new data, but they're all struggling on where to start. So we also have a consulting arm, and they developed a service which we call Guide in Big Data. And what we do with this service is basically that we sit down with our customers and we help them to in workshops with the business and the IT and all the relevant stakeholders to define use cases, to look at what data sources are there, and then we start a project, because that's what we learned. Best way is just to get started. And then our consultants, if you start doing it, getting the data, you need a toolbox. That toolbox is provided by our Hadoop as a service platform. Important to know, one of the additional elements which is part of our service is that we are an OEM partner of Datamere. So if our consultant starts a project and we really want to use real customer data, we want to have the business stakeholders involved and define use cases and then start an iterative process using Hadoop to store the data, Datamere to do the analytics, and we use Tableau to present back the results. And yeah, we did this both as internal KPN at several departments, and also with external customers. And it's always surprising what results come out of it. And there's always a lot of low-hanging fruit with very good business cases behind it. So.
Fred, thank you. Appreciate that. Johan, let's talk about the bank.
Hi, everybody. I'm Johan Swart. I'm manager of the IT Delivery Center Customer and Business Intelligence. And, well, we start exploring the capabilities of Hadoop, I think 2 years ago, in an exploration environment. See how we can optimize the service to our customers. And at this moment, we are in the middle of implementing the Hadoop capabilities in a data lake concept. Two ways, one for storage, archiving, and the second important thing for deep data analysis in the data lake concept. Okay. So, well, and I think we are in good shape now.
Okay, all right. So we've heard from telecommunications company, banking, and Thomas, right? Large manufacturer.
Yes. Hello, everyone. My name is Thomas Sauer. I work for Daimler, one of the most successful automotive companies in the world. So we have the Mercedes-Benz premium cars, the commercial trucks, and you can imagine we have the complete value chain from research, development, production, sales, after sales. And we start in 2013 with an evaluation project whether big data would make sense for us as a company. And it turned out, yes, it makes sense. So we set up our first Hadoop cluster in 2014. And actually, our first application make use of computing power, not storage. And it's about analyzing data from test cars. So we need a lot of computing power here. Before we had a grid solution, and the Hadoop is, from the performance perspective, much better. My team is a called Center of Excellence Big Data and BI. So we take care of analyzing, evaluating technology in the market. We discuss with our colleagues in the IT about architecture. We have a data science team in place where we analyze a lot of proof of concepts alongside our value chain, and we conduct POCs and implement projects currently. So there's a lot of work currently.
Okay. Thank you, Thomas. Daljit from an energy company. Yes.
Hi, Daljit Rihal. I'm from British Gas. For those of you who don't know, we're the biggest utility company in the United Kingdom. We service around about 17 million households. We have a strong presence in B2B and B2C. Our portfolio is a very complex one. We do gas, electricity, and also very exotic products like insurance for your garden shed in case your barbecue catches fire in the summer. These are sort of the sort of products of home services world that we're in. Our journey, our primary use case for Hadoop was really driven out of emotion of being the IT guy, always getting blamed for people's MI reports, data not being right. A vision that we embarked on was getting to a position where we would never have to ask our business users what their requirements were. The only way to fulfill that is by getting all your data in one place and then saying, we've got all the data, we don't need to know your requirements, you can now play. We started our journey by exploring Hadoop via, I gave my team, all sort of 120 of them, handheld Raspberry Pis, which are computers that people use for hobby projects, small handheld computers. I gave them to my team and said, go away, innovate, come back with something interesting if you have something. And a bunch of them connected their Raspberry Pis up on a LAN and put a Hadoop cluster on. That was our first Hadoop cluster. And we went from there to using second-hand laptops that we were going to discard to meeting Hortonworks. And we have gone live with about 4 of our primary use cases now. We're operational, as you probably heard yesterday, if you can remember.
Okay. Thank you, Daljit. Bernhard.
Hi. Good morning, everybody. So banking again. My name is Bernhard Kainz. I work for BAWAG BSK. I'm the Chief Information Officer there. BAWAG BSK is an Austrian bank, mostly retail. We have like 1 million customers, also mostly in Austria. Our journey with Hadoop actually began in a cost reduction initiative. We run our core banking system on an IBM mainframe, like I guess like 80% of banks.
Like many people in this room, probably.
I don't know. If you look at our infrastructure cost, like the line item with the biggest number is the mainframe. And what we have been seeing over the last years is that the transaction numbers go up and up, driven mainly by mobile and digital banking. And while this is a good thing, and customers are engaging with the bank, costs are going up too. And so we said we need to do something. And we were looking actually to get a system where we can offload transactions from the mainframe. We have been exploring that for half a year or so. There were 2 technological challenges. It's literally a lot of data. We have like millions of transactions, sometimes in an hour. And we needed to get that data onto the system in real time. And the system also needed to be fast enough to service the requests in real time, because the idea was when somebody does mobile banking, the read transactions don't hit the mainframe anymore. They go to that system. And in the end, we choose Hadoop. And we are actually very, very happy with that from a return of investment perspective. We have achieved like a 50% reduction in transaction rate. And with, if you're used to like mainframe cost, ridiculously low investment.
Okay. So it's just interesting, just listen across the different use cases from how do you front-end a mainframe, right, as a way of reducing your transactional costs and ultimately delivering better service, right, to your banking customers, right? How you think of self-service, what you can do across the enterprise. That's how you go improve your production processes, right? Leveraging Hadoop and what you can go do, right? Johan and Fred, so great use cases across everybody. I think what would be interesting now is maybe to spend a minute on how do you see Hadoop transforming your industry overall? And what are some of the ways as you think about it and say, what's the potential impact that this could have either within your business or across the industry in terms of what's possible? Daljit, why don't we start with you?
Yeah, I mean, this is a very good question for anybody in my industry. As those of you who follow the sort of trends would know, we are in the midst of this transformation. We've gone from, you know, somebody guessed what your gas bill was or your electricity bill was. They guessed once a year and applied it, multiplied it, provided all sorts of complexities. You have to have a PhD in physics to work out joule value, calorific value, and work out what you're actually paying for. We've gone from that to every half an hour, or even more immediate, we can measure your consumption in your house or at your place of business. That is that's driven a data-driven transformation in the industry. And you know, we don't have a choice. This is mandated, so we have to do it. For the first time, our industry is thinking about the customer, explain to the customer where their money is going rather than what a kilowatt hour was. They're able to now see how much they're wasting on electricity by leaving their lights on, because a personalized report is generated for each customer. The data scientists, they've not been sitting still. They've been taking the information from 2 million smart meters we've rolled out to work out a good proxy model for people who don't have a smart meter and give them similar information. So whilst they wait to be modernized, knowing this, having this data is changing the dynamics of the way the market operates, because you need to know how much your customers are going to consume in order to buy energy supply from the spot market. And if you get that forecasting model wrong, you could be, paying the penalty in several billion pounds because you have to buy, as in the case of British Gas, it's a national security. You have to buy energy for the whole country because you're the biggest operator, and you have to buy 5-6 years in advance. Having the accuracy that you can now get from big data solutions because you have that volume of data makes a major difference because we can now buy at more cost-effective, more accurate forecasting on demand side, which ultimately then translates to lower costs for the consumer.
Okay. Very interesting. So overall, providing a better consumer experience. And actually, you were telling us just as we were walking out in there, another application of it, you start looking at things like workforce management and how you make it easier, because I thought that was really interesting.
Oh, yeah. I mean, it's hard to keep up sometimes when things are happening so fast. After you put the data lake out there, things start to accelerate. One of our use cases that we are live with now is we have a data-driven product. Our engineers that go to people's houses when their central heating breaks down or there's a burst pipe or something, for the first time, they are now going to those people's houses with real-time information on their handheld devices, which is being populated through the data lake. We populate our data lake 20 times per day. So within a day, if that customer's called the call center, by the time the engineer has gone to that customer's house, they have that information. They know how many times they've complained. But not only that, but the customer is able to see on an app, the engineer said they would be here at 11 a.m. They can now go on, look at a data-driven app and see where the engineer is and whether or not they can actually, they're 5 minutes away, 20 minutes away, they can track that.
So you're saying it's not, I'll be there sometime between 8 a.m. and 1 p.m., it's here's when they're going to show up and they can see that.
Yeah, so this is a use case that we are now piloting.
I'm sure that's never happened to anyone in this audience. So.
It happens to me. So we're creating these apps, and we're piloting them, and then they get rolled out. So there's a number of them, and that is one of the ones that we've gone live with.
So ultimately, you're taking the energy industry, and what you're doing is you're providing a personalized consumer experience, right? That improves the experience, but also on the back end, it's helping you manage your costs in terms of what you do on buying and selling energy, so you can manage your supply and demand more effectively.
Yeah. And it has benefits of starting to get trust back from the consumer, as opposed to being seen the bad guy. If you make promises and you keep them, then you are well on your way of actually starting to win trust from your customers.
Thank you. Who else? So this time I won't pick, I'll let in there. Who would like to talk about from a transformational perspective in the industry? Bernard.
I can just pick up on the term customer experience, and just mentioned the second use case we actually did with Hadoop, that I think is much cooler than cost reduction. We do have something we call a customer journey, which for us is like a database where we say every interaction any customer has with us on any channel, be it self-service, call center, mobile banking, we store there. And in ridiculously detailed way, we used to have that on MongoDB. And we are now putting it on Hadoop because we are seeing that we can do so much more with it. MongoDB worked fine for us, but it's just actually, it ended as a data store. I like the term that was used yesterday during the keynotes, that Hadoop is something like a data operating system, because we have, what we are seeing is that there's so many use cases that just pop up because you just don't have the data there. You can do so much with it. You can analyze it. You can do real-time stuff with Spark, which is a very essential component for us. For example, what we are now trying out is to engage one-to-one with our customers, using this customer journey and determine how can we help the customer when he's like in a branch, he's having a problem with a self-service machine. We realize that in real time, and like an assistant can come out and help the person. And so I simply cannot stress the fact enough is when you have those data, you can act on it in real time. How many use cases you have? The problem we have is there's so little time to implement them.
Right. So overall, you're leveraging Hadoop to reduce your overall cost by reducing your mainframe workload, right? You're delivering a better retail banking experience right, to consumers.
Yeah.
And it sounds like you're also leveraging Hadoop as a data unification platform, right, to start to take many of these different data sets together into one place.
Historically, banks, I would say, have been very good with data. They need to be, for example, in risk management. There's a regulatory need to have a lot of data and to know how to handle it, but it has been done in silos, I would say. So like the risk guys, they have their database and they do their stuff with all their applications, and what banks, I think, have not been so good at is like have an integrated data platform where everything is and you can make more sense of that. And I think Hadoop is the platform for that.
From a banking perspective, do you think of things like risk or fraud or anything?
Yeah, I think our customers can benefit in a number of ways for big data technology. One is we can improve the service to our customers by providing them with omni-channel offerings, more personalized. I think a second important thing is, for example, fraud detection. So with using big data technology, we are able to do better fraud detection, looking to fraudulent activities. For example, when with your debit card a transaction is done in Brussels and 10 minutes later in New York, that's a little bit strange. So then we can automatically lock your account, make sure that, so we can prevent the fraud from it. That's an example we can use it. And of course, there are many other examples, like overrun on a debit account. We can do the customer an offer for a savings account, so they can get some interest on it. So many ways of doing it, and we are now exploring all the capabilities of that.
Okay.
And, yeah.
So good. So again, improving the overall customer experience on the fraud side for either preventing the fraud or probably preventing some false positives as well, right? In terms of something happening, so you provide a better experience overall. Anyone else on that, Fred?
Yeah, from a telco side, a lot of the things that have been said are applicable for the telco side as well. So silo channel to omni-channel, that's something which we're really working on to make sure that we get a 360 customer view and really deliver good service to our customers. The other thing is, instead of managing a network, technical network, it's not about managing a network. It's providing a good customer experience. So also there we're looking at how can we be, instead of reacting when something goes wrong in the network, be far more proactive and predictive, self-optimizing network kind of things. Basically, there's in KPN two main business drivers. We want to significantly increase the net promoter scores with our customers. Again, that all ties into everything that's been said on customer experience. And the other thing, very hard targets on reducing costs. So being more operational efficiency, automate things in the network. Also make sure that we gather all the data we have from the network, which we discarded. We used to discard after some time. Now we'll keep it. And we will make the relationship for not only getting the data from the technical data from the network, but combine it with data from other sources and really put the customer experience at the center.
And I think for the next decade, it will be very important from an engineering perspective to collect all the data. So I think for the audience, as an engineer, you will have a great future the coming 10 years especially, because a lot of things will change. I think data and analysis will become more and more important every day. So really you have to keep going with it. So yeah. So I think for the engineers, it's a great challenge.
So I want to go off that point you just made, Jan, as you're talking about it, right? So you've all obviously done things with Hadoop and are partway along your journey. How do you see this? Do you see yourselves as very early in the journey, far down? Do you think you have a lot of other things and a long runway to work with?
I think we are. I think we are really at the beginning of a new decade. I think this will be the decade of data and analysis, and exploring big data technologies. So I think things will change much more rapidly. They're already changing rapidly. Yeah? The new Hortonworks releases are getting better and better and better. Also on security, data governance. So, well, I expect the next decade a lot of things will change.
Okay.
And engineering will be key, also from a marketing perspective. We sometimes say the engineer is the marketeer of the future. So it's, yeah.
Okay.
Sorry, I would echo that. I think, yeah, you know, if you started on this journey, definitely, you know, 18 months ago, 2 years ago, you are an early adopter. Hadoop may have been around before that, but in the way in which enterprises started to adopt it, you are an early adopter, you're a pioneer. Everybody in this room who's doing that should be proud of themselves, because you know, there are often benefits to this that we don't get to mention. One thing I'd like to say is that by embarking on this journey internally, we've achieved a bit of a cultural change in our organization, in that people now are being more creative. In the past, they were restricted by applications and that, and somehow being part of this open source thing has allowed them to think differently. Right. And you know, that's a wonderful thing once you start seeing that in your organization.
My guess is from that is, I think what you're saying is you got started and you didn't even realize all the opportunities that are in front of you until you got started. It opened up new possibilities.
Yes, yes.
Okay. Thomas.
Yeah, and I think there's the big buzzword Industry 4.0, and you can imagine, for example, in our production processes in the plants worldwide, many data is generated all over, and there are so many opportunities to get information out of it for prescriptive but also predictive analytics, to reach better maturity earlier, or to reduce waste in the production process. So there are many opportunities for manufacturer, for example, but also towards the customers or within a car. A lot of data is generated while it's driving. So we have introduced Connect Me, so the new C-Class, for example, sends while it's driving data towards Daimler. So we can analyze this data, know the health status of a car, do predictive analytics, predictive maintenance also. So there are a lot of opportunities for the customer experience, to bring the things forward, new services. It's immense.
Okay. So it's interesting just listening to all these, right? Hadoop, right, many people think originally it started from how do I do clickstream analysis and target consumers and others, but everything I've heard from every one of you is it's improving your core processes that run your business, from how do you produce high quality cars faster and more efficiently, to how do you deliver your costs on the energy side, right, to what you're doing on the banking side around the core around reducing fraud. It's everyone's core process done more efficiently or more cost effectively.
Yeah, I can only stress that I think we are just at the beginning, at the early stages of a revolution. It's not so obvious. I really think that it's like when the web came out. It was more obvious this is something very new and this is going to change things because it's visible. You could see it with data, with things like Hadoop in the back. It's not so visible. But I think we cannot imagine at the moment the things that are going to come, and not like in 5 years, like in 1, 2, 3 years, which for everybody in this room, like who is an engineer, is a great story, because those people are really, really sought after.
Right, because the advancements are happening very quickly.
Yeah.
Right. I mean, just the idea of moving from batch to interactive to now real time, right? Real time from a fraud perspective in terms of what you can go do and go manage.
Yeah.
Okay. Let's talk a little bit more on the technology side now. So a couple people have mentioned governance, right, as in areas you start to look at enterprise capabilities. Governance and security tend to be the two hot topics, right, that people want to talk about. Let's talk a little bit about how you think of governance inside of Hadoop and some of the ways you may be thinking of it or leveraging it today. I'll open to the panel to go jump in.
Well, I think that looking at the future, Hadoop and all the open source capabilities around it will also change the whole data warehouse world. So we are also looking at replacing our current data warehouse by using Hadoop technology. I also expect that the open source will be integrated with other systems. For example, we are also looking at IBM InfoSphere in combination with Hadoop for tagging metadata, data governance, combine it all in a lake with the proper security around it. Because I think security is also one of the key elements we need to look at, because putting all the data together is fantastic, but we still need to keep it secure, because we don't want someone running around with the credit card numbers of our wealth customers at ING, because that won't be good. So we are extremely looking at the security, how to make that properly. And I expect that everything will integrate more and more. I also see the new releases, looking forward to the new releases coming up. We are now implementing Hortonworks 2.2 with Ranger and Cabros, which is already a big step forward, I think, from a security perspective. And I see in the new version 2.3 also some data governance implementations coming up. I think that's good. And I think the market will move forward and forward and becoming more and more mature. And then we can replace more old systems by new technologies.
So you're already leveraging the security capabilities, what you can go do for your core assets, right? Your customer information.
Yeah, of course, and we need to connect it to Active Directory to make sure that the right people get access to the right files and the right data, which is we are now implementing that. So.
I mean, banking, a highly regulated industry, right, where you have to ensure, right, the security and the governance around what you're doing with the data.
Yeah.
Before we started the session, we were just talking about the analogies between a bank and a telco provider. I mean, security compliance, data governance, they're exactly the same for a telco provider. Privacy is one of the main aspects that we're focusing on. We absolutely do want to respect privacy, and therefore you need to make sure that no one does things with the data that are not allowed. So to get this in place. And what I'd like to add about having the technology is one part. But what's very important as well, you also need to look at your processes and your organization around this, and that's often I think underestimated. It's also in getting the real value of big data analytics. It also requires business change very much, and that's so. What we see with many of our customers, that it's really a journey. So on your question, where are you? We are at the beginning of the journey because it will be transformational into many ways, but also to the way the organization works, and we need to adapt to new ways of working.
Okay,
sure. Can I just build on that? I think, for the first time in my organization anyway, because we had several data warehouses, we had several bespoke cottage industries that work their way into your organization, whether you like it or not. Hadoop is allowing us to put a policy in place which effectively stops information from flowing. We keep the data in our data lake, and if you need it, you come to the data lake, do your processing there, and take your answer back. And I think that is innate as an enabler for the first time for us to actually put in some additional security measures. In the past, trying to implement our security policies and our governance procedures in a federated, distributed environment was harder to achieve. And this is making us actually, do it for the first time in a far more effective way.
So almost two advantages on the security side. One, just from taking your data from many different places where it was secure, but putting it in one place inherently, you can control it more. And then secondarily, leverage all the security features in Hadoop today to go secure it.
Yeah, so, it just makes it, if you have less to control, you can control it more effectively. So that's one of the things that we liked about the strategy that we came up with.
Okay. Thomas, thoughts from either governance or security perspective?
So we see, first of all, how our Hadoop ecosystem or our big data ecosystem as a complement to our existing, let's say, BI data warehouse world. So it will not substitute in a big scale. Maybe some relational databases, maybe one the other data warehouse will be replaced, but in general, it's a addition. Yeah. And we need to apply, let's say, the same security standards to it. So it must be confidential, for example. So when we set up Hadoop, we put it on a strategic platform as we do it for all other business intelligence technologies. We apply the same security standards. We can adapt, let's say, some also data governance topics, but for sure we need some alignments. We need some changes, but we can orient ourselves to the classical, to the traditional world.
So it's interesting, and now listening across the three of you, right? You're talking about replacing the data warehouse, right, and moving all the data to Hadoop. You're talking about, Thomas, keeping it complementary,
yes.
right, and a modern data architecture.
I don't know what will happen in 20 years or so, but let's say the next 1, 2, 3, 4, 5 years, I do not see that in a big scale that we going to replace data warehouse.
And I think at this moment, we can replace some systems by Hadoop, but for some parts we still need some relational databases. But I think the technology will evolve, and in the future, also the SQL capabilities of Hadoop will getting better and better. So that will also mean a replacement of the relational databases, I think.
But in many ways, many of the core capabilities that you've come to rely on over the years, sounds like you're comfortable. Much of that is in Hadoop already, and you're able to go leverage that.
Yeah.
Right? You're not pioneering or starting from scratch on that, right? But interesting, replacing, right, complementing, you know, and you described taking part of the workload off a mainframe, but leaving some of it there. So it's not one size fits all, right? Everyone's doing it a little bit differently.
I mean, basically, having the data someplace is one thing, but usually what's much more sticky and harder to replace are applications. So I guess our situation will be for years to come, the Hadoop cluster and the whole data lake infrastructure will be a complement. And we will do new things there and more cooler things, but I think the older things will still stick around.
So maybe, Bernard, we'll stick with you. Fast forward a couple of years, how pervasive do you see Hadoop in your enterprise as a technology in terms of what you're doing with your core systems?
How I see it now, I might see it differently in 3 years because maybe something harder comes out in 3 years. I mean, I didn't know about Hadoop like 3, 4 years ago. We have, for example, even reorganized our IT organization and put some people in place who only do data lake. And so we will really focus on doing everything new there because there are so many use cases and so much business value we think we can create. So we will absolutely put a focus on developing the data lake and neglecting other things if resources are not around.
Okay. Sounds like a common strategy across a number of you to start to centralize your data in one place, in a data lake, right, the term you're using, and start to, for either it's easier to go track what's happening if you have it in one place, or from economics, right, to start to put all your data together. Any other thoughts on that?
I think when new data is generated and you do not have this in any data warehouse or relational database, then you go for Hadoop, for sure. But if you have an existing environment working probably, then just copy. I don't know whether this is the right approach. So there must be a business value, or let's say a new business case behind, or a use case behind, or something really new.
Okay.
I believe that we're going to start seeing going from a solution to your data problem to utilizing it as Hadoop as a platform for offloading your batch processes from other applications that are non-data. So if you have a billing system that takes all night to process month-end, I can see in the future how some of those jobs will be offloaded, get the processing done, and the answers then go back to that application. I also think the pervasiveness is now coming out into, especially in the enterprise architecture space, they're having to redefine the design patterns. Because of the third tier of your 3-tier application, there are now choices that weren't there before. So in the past, when you bespoke an application, built it in-house, you would automatically go on Oracle. Right. Now you have, what's it going to be, MongoDB, Cassandra, Hadoop, blah, blah, blah. So I think some of the applications that people do build from time to time, they will end up being built as a back end being Hadoop.
I think another big benefit of a data lake concept is because at this moment in a lot of companies we still have a lot of replication of data. Files copying around 50, 60 times through the whole company, which costs a lot of storage, a lot of effort in terms of security, etc., etc. So storing all the data in one place and be able to retrieve it, that's also a big benefit, instead of copying all the files around and around. So I think that's also a big opportunity.
Have any of you sat down and done analysis of how much data is truly across the enterprise, and then to be able to say, if I can start to centralize, how much I can go reduce that?
Yeah, and I think we can reduce a lot. So we can reduce on terabytes of data by just storing it on one place. And I think we also can go down in cost as well.
Okay. Just by centralizing.
And also getting off some legacy systems, well, my colleague was talking about.
We actually do have a somewhat different approach to that, because what I say is the value is in doing the new stuff, in doing the transformative stuff, not in getting things that are already working, that are around on the new platform. So we said that can be where it is. We want to do the new things, the cool things that have business value on Hadoop.
Okay.
So we're not touching the old stuff on purpose.
Right. Again, differing strategies. One is move some of it over to a central place from the old, and one is keep it there and just focus on the new areas. There's no one size fits all in terms of how you're all approaching and the value you're getting out of Hadoop and what you're doing. I want to go off something both of you said. Right? You talked about batch Daljit, right? Moving more batch processes off, and you also talked about updating your systems 20 times a day in Hadoop as you start to move towards more real time. And Thomas, you mentioned something, I don't know if everyone caught it, but you were talking about on the cars now saying more real time, starting to send the data back, right, from the car to start to track what's happening. It's I think, an interesting use case where it's moving towards more real time capabilities.
Yeah, exactly. But I think it will take a little bit time to be so good that we can predict really the right result, because we cannot annoy our customers with some, I don't know, meaningless messages. It must be a very good model behind. Yeah. So, but the way is towards real time. I think so. Yes. So the frequency the data is sent will be increased. The number of cars will increase, and mass of data is calculated, and diagnostics is done on this. So. It will be very big, I guess.
Yeah, and you'll leverage a lot of that predictive analytics for things like warranty repair, right, maintenance, when somebody needs to come in for service, right, and to improve that overall experience for the consumer. Right. Okay. Right. I think one thing that would be of helpful to the audience, you've all said you're still early in the journey. There's a lot left, even if you've been doing it 18, 24 months. You see a very long runway in terms of what's happening. But what would probably be helpful to the audience is there's probably people here in various degrees of leveraging Hadoop, utilizing it. Some haven't started, some are early, some are further along. If you could wind the clock back and start over and say, here's how I would get started and what I would do, or here's a lesson learned, right, that if I could impart it and share it with the audience, here's what would be of most interest. I think that would be interesting to everyone here. And Fred, why don't we start with you on the side there?
I think, first of all, it's important to realize data will be a core asset. Meaning that also the responsibility for data should be at the very top of the organization, and then of course we see a lot of organizations moving towards bringing in the role of a chief data officer. So getting your policies and then get started, but don't try to be to make too big of a step, but start many small projects. With a vision, this is where we want to move. Yes, we want to eventually move to a data lake. There's a question, and that's at least what we see in KPN, whether it's feasible to go to one central data lake in one go, or that we should have a phased approach between several business lines. To clarify this, if we look at KPN, we have the mobile network operator and we have the service provider, but the mobile network operator also provides services to other MVNOs. So can we bring this all together in one data lake, or should we have a number of data hubs across the organization? But have the vision, have the goal, get a right strategy around data, get the governance right at the top of the organization, and get started.
So what I'm hearing is it's not that you had a vision of where you wanted to go, but you didn't have it all figured out. You said, let's just get started and learn along the way in terms of what's happening.
Yeah, I can add to that. I think start with it. The proof of the pudding is in the eating, so you really have to go ahead with it. Another important thing is that I see our business partners and my business management colleagues getting more and more on board, also getting much more interested in everything that's happening, and also the role of the chief data officer. So I also see that business and IT will start working more and more together on all these propositions. So also with marketing, to look together how we can do it, how we can improve the service to our customers. So I think that's a very important change. So what Fred already mentioned, the role of the chief data officer, it's getting more and more important, and also data ownership through the whole company. So yeah, that's also a big change.
So it sounds like culturally, as you got started, the rest of the organization could start to see the benefits and come along, whether it's around who owns the data, is it secure enough, what you can go do, and once you got started, you could show those benefits.
It's really about working together now. So as one team, business and IT, it's not anymore about, well, there are some IT guys there around the corner doing things. Now it's working together, looking at the capabilities, and just do it. Go for it.
Okay. Okay. Thomas.
I think for us, it was very important to have a technical foundation in place when talk to the business partners. Yeah? So it's not enough just to show PowerPoint slides and say we could do whatever, but it takes months to have such an environment, a professional in place with all security, have the servers in place and all this stuff. And when you have this technical foundation, then it's easier in a discussion with the business partner to say, okay, here's the idea, let's start it. Yeah? And the second one is start with, let's say, smaller POCs and show what is possible, the potential, but also what is the business value, what is the business case behind. Because everyone says, oh, I see the potential, but what are the real figures at the end? Mm-hmm. And then there's a decision, go for, let's say, robust production solution, and if they have the figures in mind and they know there's a business case, then we can go forward. Otherwise, it's always difficult.
Right. So it sounds like you established the platform and got started, but then started on one project, use that to determine the benefits that you can then determine what are the other projects to go focus on. Right. Okay. Daljit.
Yeah, I think, looking back, I wish I'd had more fun because it has been, this has been a development exercise for everybody involved. I think that the challenges are there. I personally experienced as many challenges from people within IT as from outside IT, from external vendors, as well as people internally to the organization. The best thing that I do not regret this, is I took the chance, I went for it, knowing that I will have the chance to shape the answers rather than buy them from somebody else. Mm-hmm. If I've got an environment in which I can program, all I need is programmers, and that is the safety net. You can build your own code. So, my advice is, have the courage, be bold, go for it.
Mm-hmm. So it sounds like in that case, Hadoop was not only transforming the experience you could deliver to your consumers, but also internally, right? What you're doing, how you're working with the business, how you're driving things through the business, and putting more control back in the developer's hands in terms of what they could do.
Yeah.
Okay, great. Okay, Bernard. I know it's hard to go last. They've all said the good things, but you got to come up with something for the audience. Come on.
No, I think looking back how we did it, I think that it's a common thing. Like when I look at the other guys, we started with some use case in mind, and it turned out to be great, and then we went on with it, and everybody did not really realize the potential. And I think looking back is you have to find the right balance between setting up a platform, but not waiting. And while you set up the platform, discover your use cases, go for it, and produce the value for the business.
Right, and in your case, you're getting started was looking at your cost structure and saying, this is one of my highest cost operational light items, right, in my mainframe. Can I start to reduce the workload on it, start to move those capabilities?
But that's what I mean. You need to find the use cases and don't wait. That's what I would tell everybody. Get going.
Okay. Okay. So what's been interesting across all of you is different use cases in terms of how you're getting started, right? Different applications of the technology from more of a centralized perspective, from an operational perspective, how you think of governance, right, and its importance, but also the type of consumer experience. What I've heard from everybody is really starting and improving many of the core operational processes that run the business, and then focusing on some of the interesting use cases as you go past that. But that's the bread and butter of the businesses you've all built for many, many years in terms of what you can go do. So very interesting overall. So first, I want to thank you all. I appreciate everyone spending their time. I want to thank you all, one, as customers, but two, for your time on sharing this with the audience today. So thank you very much. Okay. So, okay. Well, good. Thank you. I'll let you all off the stage. Thank you, Fred. So, with that, I'd like to bring out Martin Wilcox. Hopefully he's over there from Teradata. Martin's going to give his view of Teradata in terms of how they look at it as a data lake, and building upon many of the themes that you heard here. So with that, Martin, this is yours now.
Thank you
very much, and welcome.
Thank you. Good morning, everyone. So listen, before we get going, and by way of introduction, let me tell you a little bit about Teradata. I promise I won't take long. So Teradata was founded in 1979 to commercialize the massively parallel processing model. For the non-techies in the audience, that's the computing model that underpins pretty much all modern big data technologies, Hadoop included. Founded to commercialize the massively parallel processing model and to build a relational database management system that would scale and perform so that organizations could integrate data from across their operations and support cross-functional analytics. By 1986, we could ship a system with 1 terabyte of spinning disk, even if we did need an entire truck to ship it in. And commentators like Devlin and Inman were starting to describe the phenomenon of the data warehouse. Today, we have 50 customers with more than a petabyte of data under management in Teradata, and one customer with more than 50 petabytes of data under management in Teradata. We're still passionate advocates for data warehouses and data warehousing. But if you think of us as just a data warehouse provider, increasingly, you're only 25% correct. I guess more importantly, from the perspective of this discussion this morning, we've got more than 35 years' experience in parallel computing, in data management, and in analytics. And I think that gives us a very good perspective and a useful perspective, hopefully, on where the industry has been and where the industry is headed. So if we fast forward to 2015, everyone's talking about data. The world is drunk on data, as Ranga from Microsoft memorably put it yesterday. But I guess that even those of us that are enthusiastic proponents and believers in the power of data-driven business and the ability of data and analytics to transform business and society, and I would certainly class myself as one of those, even us passionate believers have to concede that there's at least as much breathless hype as there is informed commentary in the industry today. And I think that one of the consequences of some of that hype and exaggeration is that a lot of the terms, a lot of the labels that we use to describe what's going on become overloaded very quickly. So we all start using the same labels, the same descriptions, but we use them to mean very, very different things. And that causes a great deal of confusion. And you see this very clearly in the data lake debate. Data lake discussions, frequently contradictory, are everywhere right now. But there's actually relatively little clarity on what we mean by this concept, and even less good advice and best practice that will tell you how to go about building one. For example, if you search for data lake on amazon.co.uk, the top hit is this, an academic textbook about tracking environmental change using lake sediment data. Now, I'm told it's a fascinating read, but it's probably not what you were expecting. So if the data lake is more of an architectural concept than a physical reality in most of our organizations today, now seems like a really good time to ask, what is a data lake anyway? What do we want it to be? And perhaps more importantly, what do we want it not to be? I think if you cut through the hype, most of the proponents, the advocates for the data lake architecture, are really pushing 4 big ideas. Big idea number 1 is that you should store all your data in a Hadoop-based repository. I think we need to be a little bit careful with all, and I'll come back to that later in the presentation. Big idea number 2 is that we'll store raw data in that repository, in its raw format, that we'll use techniques like late binding and so-called schemaless information management so that we can apply different interpretations to the same data at runtime, depending on the application, depending on the use case. Big idea number 3 is that we can then leverage the multiple technologies in the Hadoop ecosystem, increasingly enabled by Yarn, to process that data in different ways, again, depending on the use case. My single favorite thing about Hadoop is that incredible flexibility. And then big idea number 4 is that by doing big ideas numbers 1 through 3, we'll resolve the nagging problems of accessibility and data integration that still get in the way of genuine cross-functional analytics in too many organizations today. And at this point in the conversation, some of you, I think, could be forgiven a certain amount of déjà vu. Because while those are lofty and worthwhile ambitions, improving data accessibility and integration is what many of you thought you were building the data warehouse for. So I think one of the very first questions that we have to ask ourselves is, what are we trying to achieve here? Is this a net new capability to solve net new problems, or are we just replatforming existing analytic solutions? And if we're just replatforming existing analytic solutions, what are the implications for deploying a complex multi-user data warehouse on today's Hadoop technology stack? I see a lot of organizations, for example, going straight to application-specific single subject area star schemas on Hadoop. Now, there's a place in most organizations for application-specific data structures, but I think we have to be a little bit careful here. This isn't schemaless information management, and if we go straight to application-specific data structures without any kind of foundation at all, we're not tearing down silos, we're creating a whole generation of new silos. For a lot of us, if this is the future of enterprise information management and analytics, then the future looks a lot like the recent past and the Inman versus Kimball debates of the late 80s and early 90s. I think we can do much better than this. And actually, I think we need to be much more ambitious for the Hadoop technology stack that Hortonworks and others have given us. I think if you take the merits of the different technologies off the table for a moment, what some of us are thinking is this. The difficult, time-consuming, and expensive part of a traditional analytics project is the data acquisition, the data integration. Maybe we just shouldn't bother with them anymore. You know, when we take a traditional approach to building a data mart or a data warehouse, we think about the sort of questions that we want to be able to answer. We think about the data that we think we'll need to answer those questions. We go and identify the source systems where that data is captured. We reverse engineer the data models of those source systems. Then we create a new target data model that will enable us to integrate all of that data. Then we map the source system data models to the target data model. Then we build ETL models and code to transform the data from one representation to another. Then we layer on data quality rules. Then we unit test. Then we system test. Then we UAT. And finally, eventually, we're able to ask questions and to get answers. And that's still a rational approach for the data that we know are frequently reused and shared. But it's a relatively time-consuming approach and a relatively expensive approach, and it means there's lots of difficult and unglamorous work that we have to do up front before we're clear in very many cases about the value of new data sets or new analytics for a particular use case, and about exactly how we want to go about implementing. So-called late binding or schemaless information management involves capturing raw data and applying multiple different interpretations to it at runtime. This is a brilliant model for capturing data whose structure changes continuously. If you're capturing raw device log data today, probably you're not modeling that data, or at least all of that data relationally. Because if you do, in the traditional way, by assigning each attribute to a column in a table in a physical data model, you risk having to revisit that physical data model and all of the associated ETL processes every time you make a change to the device firmware so that the device is capable of capturing new information about its environment. If you're capturing raw clickstream data today in the way that the big web properties do, you don't model that relationally for exactly the same reasons, right? The big web properties make hundreds or even thousands of changes to their website every single month. Mapping each one of those attributes to a column in a physical table, you just can't cope with that level of change in organizations. So late binding, schemaless information management, a brilliant way of dealing with this data whose structure changes continuously. But of course, in information technology, there's always a but. And the flip side of flexibility is, well, flexibility. If I give users, application developers, multiple ways of interpreting data, I give them multiple ways of potentially interpreting it incorrectly. Assuring data quality is much harder without a schema. And schema-on-load approaches also give us the opportunity to optimize access paths so that more users can get more answers to more questions more quickly, which is clearly important to us in many large organizations. I think, put simply, It's not that schema on load is bad and schema on read is good, or vice versa. It's that each strategy makes more or less sense for particular data assets and for particular analytic use cases. I think the whole industry now agrees that there isn't a single silver bullet information management strategy, far less a single silver bullet information management technology that makes sense across the whole across the whole big data space. I think we're all now at a point where we pretty much all agree that a more distributed analytic ecosystem is what we need to address that entire spectrum of big data requirements. We can't yet agree whether we should call that a modern data architecture, a logical data warehouse, an enterprise data hub, or the term that we like at Teradata, a unified data architecture. But essentially, these labels are all synonyms for the same thing. They're all synonyms for this more distributed analytic ecosystem. And when I told you before that if you thought of Teradata as just a data warehouse provider, you were only 25% correct. That's because at Teradata, we think there are 4 essential capabilities to building out this logical data warehouse, this distributed analytic ecosystem, and we have technology and solutions across all 4 spaces. So now we know what we don't want the data lake to be. We don't want it to be a retread of the departmental data marts that many of us have spent the last decade consolidating into an integrated data warehouse. And perhaps more importantly, we know what we do want it to be about. The flexible and agile acquisition of large volumes of raw and unmodeled data so that we can perform new analytics. And we want to be able to do all of those things cost effectively and at scale. Now that is net new, and that's potentially very, very interesting and very, very useful indeed. But why the weasel words? Why only potentially? Well, I get very nervous when I hear some commentators apply a scientific metaphor to the data lake and say we don't need governance and information management in this environment because this is only about exploration and research. You see, I was briefly a research scientist, not a very good one, which is why I'm stood in front of you today. But I was a research scientist for just long enough to understand that the basis of all sound experimental science is repeatable process and reproducible results. And what price repeatability in our analytic experiments without some level of information management and without some level of governance? And even more importantly, many of us want the data lake to be a source, to feed downstream systems, including the integrated data warehouse. And since any since any chain is only as strong as the weakest link, if we can't answer basic questions, where did this data come from? Who created it? What did they think it represented? How has it been changed since? If we can't answer these questions for the data lake, increasingly we can't answer these questions for the entire organization. We spoke about science earlier, and those of you that studied physics will know that order does not emerge spontaneously in nature. It requires a net expenditure of energy. I see a lot of commentators suggest that a data lake will spontaneously emerge from a collection of successful Hadoop applications. I think that's to confuse integration with consolidation, and they're not the same thing. We have customers at Teradata that 3 years after starting their Hadoop journey already have 20 sizable Hadoop clusters in production. Now, there's nothing wrong with multiple Hadoop clusters if each one pays its way, but that's clearly not a sustainable trajectory. There's a wave of Hadoop cluster consolidation projects coming to many organizations near you soon. Nothing wrong with those consolidation projects either. They'll help cut costs and they'll help improve interoperability. But we need to be careful, I think, that we don't trade short-term agility for medium-term organizational sclerosis. Because those consolidation projects will suck up resources, financial and human, 2 years down the road from now that we then can't use to deliver new projects. You do yourself a big favor, I think, if you architect for consolidation up front rather than after the fact. Okay, so what does all this mean for how we should design, architect, and manage the data lake? We don't have a lot of time to go into this today, but at Teradata we advocate a layered data lake architecture. Land the data in a landing zone, pass it externally and internally to generate a minimum metadata set, store raw data in HDFS, leverage relevant technologies as well like ORC file and Avro, and then create a consolidated store, which is where we have the application-specific data structures, typically using Hive and HBase. This is a keynote presentation, and I'm not here to schlep Teradata products and services, but I'll just briefly mention the dashboard engine that we announced earlier this week, because it's a really nice example of some of the new things that we can do with Hadoop that weren't easy to do before. Multi-dimensional analysis on structured and unstructured data without kind of cube explosion problems, and because it's a great example of this layered data architecture in practice. think it's really important to remember in all of this as well that architecture and technology are only enablers. I have no problem with IT-led projects, particularly where complex and new technology is concerned. I get much more nervous about IT-only projects, and I see a lot of IT-only projects in the big data space at the moment. I think the problem with IT-only projects is that we tend to frame the problem in terms of the data and analytics that we already do, that we already support. In most cases, the real value of the Hadoop ecosystem is that it's ideally placed to help us solve problems that in most organizations we don't solve today. Using text analytics to understand which customers are complaining about what and whether those complaints are likely to escalate. Extending existing credit risk models, for example, in finance, using graph analytics. Understanding what drives customers to the website and what they do when they get there. In most organizations, we add far more value when we tackle these new problems than when we just re-platform existing analytic solutions. And aligning our projects with business objectives helps us to understand which data are relevant to the problems we're trying to solve so that we can get going quickly rather than trying to boil the ocean and capture all data. So summary and conclusions from me on all of this. The Hadoop-based data lake isn't yet the prototypical use case of Hadoop that some of the hype would have you believe, but it very soon will be. This idea of schemaless information management, of being able to apply multiple interpretations to the data using multiple different tools and technologies to solve net new problems is an incredibly powerful one. There are broadly two schools in the industry right now. What we might call the right-wing conservatives want to turn the data lake, want to build the data lake the way they built the data warehouse. This is a mistake. In the best case, we end up recreating a capability that most of you have already invested in, and in the worst case, we take a giant leap back to departmental data marts. But the left-wingers who think that everything that we've learned about enterprise information management in the last 30 or 40 years is entirely irrelevant and obsolete and we should just tear it up and throw it away, they're equally misguided. That way lies a data swamp, not a data lake. Perhaps a better metaphor would have been data reservoir. This thing needs to be architected, designed, and managed, just not architected, designed, and managed like the data warehouse. And because this is a both and, not an either-or proposition, integration really is a critical consideration, which is why we're so excited about our partnership with Hortonworks. I'm out of time, and so I'm going to leave now, but thank you very much indeed for your time and attention this morning.
Thank you, Martin. Thank you. There you go. Let's dance. I appreciate you taking the perspective on Teradata. So, one more session for today, and pleased to bring up our co-host, Yahoo, who's going to talk about their view of Hadoop, and again, being one of the earliest users of Hadoop, how have they started with, but also, more importantly, what are they doing now as they've gone along their journey and seen the opportunities, the potential of what they can do with Hadoop. So with that, Peter Kanuta, Vice President of Engineering at Yahoo, welcome you up, and thank you very much. And thank you again for being a co-host.
Thank you. Hi, I'm Peter Kanuta. I'm responsible for the Hadoop and machine learning platforms at Yahoo. And I'm really excited to be here. I'm originally from Belgium, but I've been living in California for the last 15 years. So this is the first time I'm actually back to give a talk here. I'm going to cover some of the changes we've made to our Hadoop software and hardware infrastructure to do large-scale machine learning. We started with Hadoop about 10 years ago almost, and we've been consistently increasing our footprint. At the moment, we store about 600 petabytes on 43,000 servers and run about 1 million jobs a day. The majority of these jobs are still traditional ETL and business analytics jobs, but machine learning has become an ever-increasing percentage of our footprint. Our goal is to make our Hadoop infrastructure the single best platform to run large-scale machine learning on. So machine learning at its essence is pattern recognition. You give it a set of examples with expected outcomes. The algorithm will learn the patterns in that data, and then you can use it to make predictions in the future on data you have never seen. We use it all across our business, from deciding which article to show you, which ad to show you, but also to keep our users safe. removing spam, abusive content, and identifying and blocking hacking attempts. In our business, the quality of our machine learning algorithms has a direct correlation to our revenue and our user experience. So it's really important for us. Let me give you 2 examples of, I think, interesting use cases. First, photos are just very important to our users. People upload billions of photos to Flickr, which is our photo sharing site. And we store all those photos on Hadoop. With the explosion in number of photos, a key problem becomes how can we identify beautiful pictures within either your collection or the public photos. People make a lot of photos public on Flickr, and we want to show up the really nice ones. Because we were already using deep learning to recognize objects in photos to power our search experience, we're going to try, can we use a very similar algorithm to identify automatically, just starting from the pixels, the most beautiful photos? Here you see a kind of a typical set of photos that people upload. Those are public photos on Flickr. And the majority are kind of like the normal pictures. And from time to time, there's some really beautiful pictures. So how do we identify those? So we start, like any machine learning algorithm, you start with examples of what beautiful pictures are. And we have those because people interact with their photos on Flickr all the time. They like the photos, they view them, they comment on them. So we have a very good set of beautiful photos based on user interaction with the website. And we can use that then to learn a deep learned model. And the nice part of starting from examples is that you don't have to get into some philosophical debate of what is a beautiful picture or what's beauty or art. You just say, well, beautiful pictures are the ones that our users find beautiful, and that's it. So we learn a deep learned model, and we use GPUs for that, because deep learning algorithms are very CPU intensive, and GPUs, or graphical processing units, are about 10 times faster, at least, on this particular algorithm. And this brings me to the first big change in our Hadoop infrastructure. Up to recently, the majority of our Hadoop clusters are pretty much homogeneous. They're typically 3,000, 4,000 nodes of normal servers. Yes, they might have several generations, some a bit older, some newer, but they're really just normal servers. Our newest ones aren't like that, though. Not only do we still have the old servers, we still have, the servers, but now we add several racks of very high density GPU compute in the same Hadoop cluster. This enables us to make our GPU capability available to all our engineers in a pretty cost-effective way. So we run it, and then at the end, we end up with a neural model. And because all of our photos are already on Hadoop, we can just evaluate all of them and come up with the most beautiful ones. Once we have this prediction, we can then use it to power our user interface. Let me show you the results on a day of uploads of public pictures. Up above, you see the top 2% per the algorithm, and down below, the bottom 2%. I think you'll all agree with me that the algorithm works. Clearly, the pictures there are, well, they're certainly way better than any I ever took, but it actually works. And so now that we have this capability, we can now change our user interface to actually show within your private collections what are the nicest pictures, and then the same in our public collections. So beautiful pictures is nice, but we make money too, or we have to. As you know, the majority of our revenue is advertisement-based. And I know nobody likes annoying ads, but with the right algorithms, we can make the ads much more targeted to the user and much more relevant, and that improves the user experience, because you're much more likely to either like the ad and then click on it than not. It's also great for our advertisers because it reaches the right audience. So the key algorithm here is called click prediction. And what do I mean by click prediction? It is given a particular user, a particular ad, and a particular page or context, how likely is this user going to click on that ad? The better you can make this prediction, the better we can show, the better ad we can actually show you, because we have a pretty good estimate of if you're going to like it or not. So this is a very important algorithm. And it's an ideal algorithm to use machine learning on. So we start with examples, and we have a lot of examples. As part of our normal ETL flow and our normal clickstream analysis, we have logs of every single user, web page, and ad, and if they actually clicked on it or not. And we have many, many, many billions of entries in this data that is constantly being generated by our normal flows on Hadoop. And we use those samples to create a predictor. And research has shown, and our own experience has shown, that scale makes an enormous difference here. And what do I mean by scale? In the end, if you look at these machine learned models or predictors, they're really a set of numbers. They're just numbers called parameters. And the more parameters you can actually learn, the more accurate your prediction can be. And with Hadoop, we've been able to scale the number of parameters we learn from the millions to the hundreds of billions. That's a 5 order of magnitude increase in scale. And those have given us enormous benefits in accuracy of the prediction. Just to put this a bit in perspective, simply storing these hundreds of billions of parameters takes terabytes of memory, and we need it in memory for performance reasons. So let me go into some technical detail here on how we do it. So we start with all the examples as part of our normal ETL flow in Hadoop. They're on HDFS. And then we use a set of learners. They're really mapper tasks. We use Spark on Yarn for that each take a piece of the data and run the learning algorithm. They do that by communicating with the parameters that are stored in parameter servers, which also runs on Hadoop. These parameter servers are a custom key value store that we implemented specifically for this purpose. And so they basically take some data and then update parameters in the parameter server. And at the end of the run, all the parameters get stored on HDFS again, from where they're taken up by the rest of our advertisement systems for serving purposes. There's a couple of things I really want to point out here. One is we also use heterogeneous clusters here. We use high CPU nodes for the learners. They need a lot of compute, but not a lot of memory, a couple gigabytes, while the parameter server run typically on servers with 256 gigabyte or more. And we use a feature from Yarn, both here and in the previous GPU example, called a label-based scheduling. And this enables us to make sure that each piece of the software gets run on the appropriate hardware. There's a second point, which is a bit more subtle, but very important. It is the communication between the learners and the parameter servers. We don't use any standard Hadoop. This is not MapReduce here. We don't use any standard way. We have a custom asynchronous communication protocol here. And you might ask, if you're working in the database world, is how do we synchronize this? How do we deal with thousands of mappers doing hundreds of millions of accesses a second to these parameter servers? And in short, the answer is we don't. We actually give up and relax the correctness requirement. And I think it's a very important point here. We know that in this communication, things are going wrong. We actually know that one will override the other. And we give up correctness in exchange for multiple orders of magnitude in speed. And this works because the machine learning algorithms are really designed to deal with noise in its data. So they detect patterns. The core part of what they do is detect patterns in presence of noise. And you can have noise in the input data, but if you have noise in the actual compute itself, they can deal with that as well. So we give up a tiny bit of accuracy for multiple orders of scale and speed improvement, which allows us to run through way more data at much larger scale, which makes up significantly for the loss in accuracy. So we end up, at the end, with a system that is both much faster, much bigger, and much more accurate. So this is pretty new. We're pretty happy with the overall results here. So if I summarize, we use machine learning everywhere, from providing innovative user experiences, keeping our users safe, to powering our advertisement systems. And Hadoop has proven for us to be the single best platform to run these algorithms on. We've made really two big changes. One is adding more custom hardware for the algorithm at hand while being integrated on our same infrastructure. And second is experiment with new programming paradigms and models that trade off accuracy for speed. Looking back a bit, we started Hadoop about 10 years ago for a very niche application, web search. Then over the years, we have added it, it became clear to each, it became central to each part of our business, and now everybody uses it. And more recently, we've really pushed the boundary in large-scale machine learning. The thing that has enabled us to be successful here is a very solid base of HDFS, where all of Yahoo's data is stored and available to all of our thousands of engineers in a secure way. And Yarn, which gives access to all of our engineers to these 40,000 machines, again, in a very controlled way, but still very cost-effective. At the layer above, I think a lot of the innovation has happened. And I think that's great. We use MapReduce a lot. We still write new MapReduce applications, and it isn't dead. But we also use all the others, Storm, Spark, HBase. We use all of them, and we're experimenting with new ones. I think this is the strength of the ecosystem. Every group in our company can use the tools that are best for their application while using the same data and the same compute. So I think we've seen a lot of progress with Hadoop, but we're at the beginning. I think machine learning, and especially machine learning at very high scale, will change our society, and Hadoop will be a central part of this. If you have any questions, you can find me at the Yahoo booth. Thank you.
Thank you. Thank you, Peter. So it's interesting to see someone who's obviously been using Hadoop for a long time, and as they've gone along their journey, how pervasive it is at Yahoo, but also how they leverage it now for machine learning and really take advantage of the centralized architecture where by having everything based on Yarn, all the other types of workloads that they can go leverage, whether it be Spark on Yarn and what they're doing there, streaming and Storm, providing a plethora of use cases and opportunities in terms of what they can do. So now we have a really interesting session. I'd like to bring up Ben Hammersley. Ben is a futurist with the European Commission, also a commentator on BBC. But what I think he's going to walk you through now is you've heard a lot of different things, a lot of technology, a lot of business use cases, et cetera. I think what Ben's going to take you through is kind of the global importance of all of this and how you think of that. So thank you, Ben.
Thank you very much. Good morning. Hiya. Ladies and gentlemen, congratulations. You won. You won. You know, 30 years ago, when I got my first computer, and many of you probably did as well, a ZX Spectrum, represent? Absolutely. You tell the Brits in the audience. When we got our first computers, you know, 30 or so years ago, having a computer, programming, was an extraordinarily nerdy thing to do. A sad and lonely thing to do. We were not cool. But we won. We run the world now. All those people in school who were the athletes and the cool people, well, we won. And now we have a problem. We live in a world that is completely dependent on the technology that we've created. And yet the people who run the world fundamentally do not understand it. They don't understand its power today, and they don't understand the evolution of that power over the next few years. Only a few miles from here is the European Parliament and the European Commission, some of the most important people in the world. And if they were in this room right now over the previous couple of hours, they would have stared at the screen and the speakers that were on this stage, and they would have dribbled slowly into their coffee. Every single technical concept that has been said on this stage and in the rooms around us over yesterday and will be spoken about today means literally nothing to the people who run the planet. This is a really big problem. But we know what's going on, right? Everybody in this room knows what's going on. We understand Moore's law, for example, the doubling of power every 12 to 18 months, you know, the secret phenomenon that enables the CEO of Apple to stand up on stage like this every September and instantly make the phone in your pocket a bit shit. We understand that power, right? We understand the potential for big data, for data lakes and data warehouses and data moats and data streams and data rivers and data ponds and data oceans, data liquid planets. I'm sure we'll get to that metaphor sooner or later. We understand the power of all of these things, from everything from genomics to city design, from designing cars or running utilities companies. We understand all of these things, and yet when we go home, back to our organizations or back to our countries, and we speak to the people who are in charge of these things, they have literally no idea. And so it's our responsibility, therefore, as a community, as developers, as business people, as entrepreneurs, to learn to communicate what is possible. Not just to each other, like we've been doing already this morning and we'll do for the rest of the day, but to the rest of society. Because this is a really big problem. The rest of society, the normals outside, are freaked out by the stuff that you do. Because not only are the jargon words and the technologies that have been spoken about today kind of weird, but when you look at precisely the power behind those technologies, they become deeply creepy. We work on technology which is on a continuum from cool to creepy, and we don't really know where to place it at the moment. Machine learning, artificial intelligence. If you speak to anybody about artificial intelligence, the first thing they say is Terminator. The nice man from Yahoo is going to kill us all. And so this is a problem. But at the same time, we totally don't understand the place of technology in everybody else's lives. As people who've lived with technology, who've lived online for maybe our entire lives, who've lived with technology since before we can remember, it's very difficult to empathize with normal people, to understand how they see the stuff that we use and the stuff that we talk about. We're really not very good at that. And we haven't understood how the technologies that we talk about have become a very serious part, not only of people's minds, but of people's bodies. As an example, everybody here undoubtedly has a smartphone, right? You've all had a smartphone for at least ever. Some of you remember trying to put Java applications onto a Nokia phone and swearing about it, right? You know, there's a handspring visor, everybody, you know, all that sort of stuff. We've all had these for a long time. And so they're quite normal to us. We see them as technological things. But over the past few years, everybody else on the planet has got one. In fact, the International Telecommunications Union in Geneva, a few 100 miles down the road, they've said that by 2020, 80% of the planet will have a smartphone. That's everybody apart from small children and old people on the planet will have an iPhone 10. Right? And all of those people have been affected in a deeply specific way. For example, everybody in this room right now has a part of their brain, it's at the back of your head, it's about here, that is constantly thinking about your phone. All of you. Right now there is a little voice in the back of your head. If you're very quiet, you can hear it. And the voice is saying, is it ringing? Is it ringing? Is it ringing? Should I check Twitter? Is it ringing? Is it ringing? We know this. There have been plenty of medical experiments about this. There was one from Harvard a couple of years ago, and it found that for people who'd had a smartphone for more than a year, 98% of people who'd had a smartphone for more than a year, that little bit of their head was constantly thinking if it was, asking if it was ringing. And every month, on average, that little bit of your brain would go wrong. And you would feel the phone vibrating in your pocket when it wasn't. This is called a phantom vibration syndrome. Everyone here has that. Because this technology has become incredibly intimate to you. Everybody in this city has that. You go outside, you ask anybody, do you feel vibrations in your pocket when you least expect it? They'll say yes. After they've looked at you strangely. 48% of you, so let's say everybody at the front bit here, all of you guys, you will have felt in the last month your phone vibrating in your pocket when you were holding it in your hand. They're weird, right? But we have to understand that this is a symptom of technology becoming incredibly intimate. Really very important for people. So when we talk about machine learning and all of this sort of stuff, we're not just talking about stuff that's happening behind screens in big boxes that sit on desks. We're talking about things in our pockets that are making our brains think our trousers are vibrating. So we really need to understand, in the general culture, precisely how important these systems are. Because before we can talk to people in the rest of the world about the things that we do, we have to understand their relationship to technology. And that relationship is incredibly sensitive. Take smart cities as an example. Ooh, smart cities. The finest of buzzwords. Where you can apply big data to millions of people and sell a shitload of stuff to cities. You know the idea, right? You take a city and you put sensors on everything that moves or doesn't move or makes a noise or emits a gas or anything. Just if we can make a sensor, we'll put a sensor on a thing. And we'll take that data and we'll have enormous amounts of data. And then we'll use that data to optimize the city. We'll make the city amazing by the power of data. Yes. And we'll pay for it by selling an iPhone app that enables people to catch a bus. It'll be awesome. We'll optimize things. But it turns out that's actually a bit of an issue for normal people. Let me give you an example. There's a Danish city called Aarhus. Is anybody here from Aarhus? Great, I can talk about them behind their back. Brilliant. Aarhus, it's a very beautiful city. It's like the second or third biggest city in Denmark, and it's incredibly pretty. It's a university town in Denmark, which means it's filled with Danish students who are the most beautiful people in the world. And it has the most pavement cafes per capita than any other city in Europe. It consists entirely of cafes, pastries, and beautiful people. It's absolutely gorgeous. And because it's Denmark, everybody cycles everywhere. So you have beautiful people on bicycles cycling past cafes. And of course, they got very excited by smart cities. Their university has a smart city research department, and they have lots and lots of vendors arriving in minibuses. You have people from IBM arriving in identical suits, and they sell stuff in. Here's some software and some stuff, and you can use this to optimize your city. Who's congratulations, yay! And they ran this software, and they found that the software's idea of optimizing the city was optimizing the commute time, the time it takes for people to get from their home to their office. And for IBM engineers in Austin or somewhere else in America, that optimization is speed. Because you're in a car on a freeway and you want to get to the office as fast as you possibly can. But for Aarhus, the optimization is not for speed. The optimization is instead for pastries. You don't want to optimize your bicycle ride for getting there as fast as you possibly can. You want to be routed in a way that takes you past a cafe just as they're taking the pastry out of the oven. You want to optimize your city not for ease of passage. You want to optimize it so you go past the best-looking people on your way to work. You want to optimize for romance, for poetry, for the blossom on the trees. You want to make your city gorgeous. You don't want to get there really fast. You want to get there slow and happy and fed and with gorgeous people in your eyes. And that is what real optimization is for. It's not making the numbers smaller. It's not a latency problem. It's not ping time. It's asking the people in the society, what is it that is most important to you? We'll optimize for that. We'll take the data that you're producing just by living, and then we'll look at it and we will find genuine cultural need. And that's not a technological problem. That's a social problem. That's a cultural problem. That is a political problem. And so suddenly we find ourselves as technologists not working with numbers or with data, because that's lovely and pristine and comma separated. Ooh. No. It has angle brackets and they're so lovely. We're talking about people and their needs and their desires and their political beliefs, and they are weird and they smell and they talk to you and ugh. God. And so when you guys appear and you talk to politicians or managers or just the random people on the street and you say, hey, we're going to optimize your stuff, they say, well, I'm not a cell in a spreadsheet. I'm not a line on a big data file. I'm not some bits in a data moat, because that sounds great. They say, I'm a person with real desires. And when you have that mismatch, you find that people cease to trust you. They look at the stuff that you're proposing and they say, yeah, you know what? Nah. Because I don't want to be optimized. I don't want to be managed. I don't want to be analyzed. I don't want to be predicted. I don't want you to take my stuff and sell me things. I want to go about my day, and my day involves cycling gently through the blossom to get to the nice pastry so I can look at that pretty girl. And governments, whether you're talking about the European Commission here, or you're talking about your national governments, or your city governments, or your state governments, reflect that fear. Because they're people too. At the same time, though, At the same time, we as humanity face enormous problems. Problems much more important than how pretty my cycle to work is in a Danish university town. We've got massive illnesses breaking out around the world, epidemics and so on. We have climate change, the fundamental challenge for the rest of everybody else's life. Population pressures. We have a global financial system that has become self-aware, or at least so complex that nobody really understands it. And so we're facing a world that has huge, huge problems. And we're here in this room and the other rooms at this conference talking about a technology that might be able to help to solve those problems. But we're talking about it in a way which is freaking everybody else out. And we're using words and language which nobody apart from the people in this room really understands. And so that's a problem. Hadoop has become a very big deal over the past few years. Apache has become a really big deal over the past few years. 30 years ago, none of this stuff existed, and now look at us. Look what we built. Fucking internet. Holy shit. But outside of this room, outside of the understanding that you have, outside of your engineering teams, outside of your product teams, people don't understand what it is you do and are really, really scared of you. Because, as I said before, you won. And not only did you win, you won really hard. There isn't a single thing that you will interact with today that hasn't been invented or refined by one of your brethren. So, what is your real job for the rest of this year as individual developers? What's your real job as a community? What is the thing that you should be really looking at doing, apart from all of this amazing invention? I would say the real challenge that you have isn't in debating the meanings of certain metaphors or standards wars or any of that sort of stuff. Your fundamental overriding need is to take what has happened in this room today and what will happen later this afternoon and what happened yesterday and take all the stuff that you do at work and turn it into real, normal language. Every new art form, every new way of expressing itself, every new way that humanity expresses itself develops a new language, a critical language, a way of describing it. Music has a huge vocabulary of words to describe and talk about music. Cinema has the same. And no matter what language you speak when you're at home, there are many ways of talking about cinema. There are many ways of talking about food. There are many ways of talking about politics, of having a generally educated conversation with each other around a dinner table about that topic. And yet the most important technology in the world, the stuff that you do on a daily basis, there is no way you can have that discussion on a Sunday afternoon with your parents. There isn't a single person in this room who has a job that anybody else in their family understands. Right? And so your job for the rest of the year is to work out how we can talk about the things that you've heard about today, not to each other, but to our friends and family and our political representatives and the leaders of our countries. Because the things that we do, the technologies that we invent, may just hold the solution to some of the biggest problems that we face as humanity. But at the moment, none of you can explain it to a normal person outside. When you can explain it, when you can talk about it in a way that is understandable, then people will embrace it. And they will look to you for solutions to some of these problems. And when they do that, I think that the technology we talk about today can really make a difference. I think we, as a community, can really fundamentally make the world a better place. But before we can do that, we have to persuade the rest of the world that we're not crazy and we're not building artificial intelligences to take over and kill us all. But instead that our ideas are powerful and good and worthwhile. And if you can develop a language to discuss those things, then the world will be a much, much better place. And your position in it will be even better than it was at the beginning of this week. Ladies and gentlemen, thank you very much and good luck.
Thank you. Well, thank you, Ben. Obviously, very interesting presentation. It's always good to learn that you have new problems like perpetual phone system syndrome and trying to figure out how to describe what you do to your family. Anyone else have that issue here in the audience? Yes. So if you indulge me for about 3 minutes and then we'll wrap up. I'd just like to give a couple things I think we saw over the course of this. So first, over the course of the session, we started with, there's 3 core trends we saw across the groups, the abstracts, and everything that we saw as this whole conference was getting put together. First, really is what's happening with the transformational capabilities of Hadoop and how are businesses leveraging that in their enterprises and across their industries. And hopefully you heard a lot of that across the panel and many of the sessions that we went through. Second, many of the enterprise class capabilities that are in Hadoop today, whether it be security or governance or operations. You heard a lot of that from Arun and others who went through what's there today and also what's coming. What you heard from Yahoo in terms of where it's going, what are some of the use cases they leverage Hadoop for as they start to go through their journey and continue to expand upon it. And then lastly, the pervasiveness. Right? Hadoop is pervasive in terms of what companies are doing and the extent to which they're getting value. But overall, most companies are still early on in their journey. The amount of opportunity in front of us of what you can do by starting to unify the data in a common platform and what you can do once you have that is enormous. And I think the common theme you heard of is once you get started, it opens up all the other opportunities in terms of what you can do. So overall, I want to thank for sure all of the sponsors and everything that they've done, especially our diamond sponsors, EMC, Teradata, Microsoft, and SAP, for helping to put this on, because without this, we couldn't put this whole event together. So first, I'd like to thank all our sponsors. Second, these types of events don't come together without a lot of organization. So I want to thank all the people on the Hortonworks, the Yahoo team, and the events who put this together and make it a flawless event for all of you as you're here. So I want to thank all of them for everything that they've done. And lastly, what I really want to thank is all of you, really the community, for what you have done, because without all of you, this wouldn't be possible in terms of what the opportunity is with Hadoop and where we can go. So overall, as a community, we're certainly beholden to you, and thank you very much for everything that you do. So with that, for the remainder of the day, there's about a 25-minute break behind us in the community showcase. Then it will go into the session abstracts for about 2 sessions, and then a break for lunch and the rest of the day. So with that, I hope that we can see many of you in Hadoop Summit in San Jose, and I hope we see all of you next year in Hadoop Summit Europe, which we'll hold again next April. Thank you, everybody. Enjoy the rest of the day.